Welcome to qnawire.
We're given an apparatus that is anchored at point O. B then rotates around that 10 inches away with velocity VB. Then there's a 20-inch long bar that connects to point A, which is in a slot, so that VA is confined to only move in this direction that is 20 degrees above the horizontal. And we want to find the velocity of A. So first we can find the velocity of B. Pretty simply, that's just going to be omega times the distance between O and B. So just the radius there. So omega was 0.8, OB is 10 inches, so this should give us 8 inches per second. So fairly simple so far. And that has to be acting directly vertically downwards. And we know it's acting in that direction because that's a right angle from OB. We can then calculate this angle right here, which I will call theta, to find some directions here. We can get that looking at the cosine of theta equals the length OB divided by AB. Because in the actual question, we're given that at this point, O and A are in a vertical line with each other, even if my drawing is a little bit off there. So we can use the fact that we have a right triangle here and find that theta is exactly 60 degrees at this point. We can then draw a velocity diagram to help us consider this situation a little more clearly. We have VA, we have VB, we have a VA with respect to B, and we know the angle between these should be our angle theta. We know angle A should be, or velocity A should be 20 degrees below the horizontal. And we can also look at the velocity of point C with respect to B, which will be directly along this bar, and point C is right in the middle of the bar there. Velocity of C with respect to B. So just in case we need that, I like identifying all of my potential velocities here. So next we can find the velocity of A which we can get by using the law of sines here. So the velocity of A divided by the sine of theta should equal the velocity of B divided by the sine of this angle is a little bit more complicated. So we take the velocity of B and we're looking for, I'll highlight this angle over here, and we can figure out what that angle is geometrically. We know we have the angle theta down here. We know this angle, which I'm actually going to switch to blue for, has to be 90 degrees minus that 20 degrees. So that angle should be 70 degrees. So our angle, our green angle then, should be the total angles in a triangle minus theta, which is 60 degrees, minus that 70 degrees, which leaves us with just 50 degrees then. We can use this then to solve for VA, to find that A is moving with a velocity of 9.05 inches per second. Next, we can do the same thing to find or the same kind of thing to help us find the velocity a with respect to b. So we take the velocity of a with respect to b over the sine of that 70 degrees, and that equals the velocity of a over the sine of theta, which was 60 degrees. We solve this for velocity of a with respect to b, and we get about 9.82 inches per second. We can then use that to find omega. So omega for the bar AB would equal the velocity of A with respect to B divided by the length AB. Since we know both those, the length of that bar was 20 inches, we get about 0.49 radians per second. So I'm going to scroll down a little bit here and change colors. We can then find the velocity of C with respect to B by looking at the ratio of the lengths. C is halfway along that bar. So if C is halfway along that bar, it must be moving with half the velocity relative to B that A is. So V of C with respect to B would equal the 10 inches divided by 20 inches. This is just a ratio here to get the speed of the halfway point when compared to the end point with respect to B. So this gives us 4.91 inches per second. We can then use the cosine rule to find the actual velocity of C. So the velocity of C should equal the square root of the velocity of B squared plus the velocity of C with respect to B squared minus 2 times the velocity of B times the velocity of C with respect to B times the cosine of that opposite angle from CB, so that theta. And then we just have to put the numbers in, and we find that we get a velocity of 6.98 inches per second.